Move on to the graphics section. What I've showed you so far is a little bit of just sort of what's called base R graphics, and these are the original graphics functions that were written going back to the 1980s and into the 1990s. This guy, Hadley Wickham, that we've mentioned as being the developer of Gplot, also developed a really nice package called Gplot, which many of you may have heard of. And so Kelly's going to talk about some of the more recent plotting packages that make it easy to make really nice graphics, including the Lattice package to some extent, and then a focus on the Gplot 2 package. And I particularly want to thank her because she did some work to update these materials in the last few weeks. So thanks for your work on that and for presenting this one.
Sure. So basically, if you're ever doing data analysis, you're going to need to make plots. It's the best way to convey information to people, and you want to make pretty plots. So R is a great way to do that. So I'm going to talk through baseplot just briefly. You've already seen it. I'm going to go through sort of the general syntax and theory for Lattice and Gplot, and then I'm going to show them side by side. So I'm going to quickly run through like a bunch of plots just so you can see what they look like. And then finally I'm going to show you like some additional options for customizing them and how you really maximize the information on your plots, and then some random stuff like how you export them. So generally, baseplot is great, but it's quick and dirty. It's not the prettiest. Lattice and Gplot take a lot more effort to make nice plots, but it pays off. They look really nice. So the Olympics, I think, just ended. So I thought it would be interesting or timely to play with some Olympics data. This came from The Guardian. They had the names of everybody who ever won an Olympic gold medal, or not gold, any medal, starting in 1896 up to 2008. So we have their name, their gender, their country, and we're actually going to use the country code, NOC, in this data set, what sport they did, and then what type of medal they won. But for plotting, we don't really care about names. Like, how would you put names on a plot? We are interested in trends over time, so we're going to look at counts. So here's just what the data looks like if you print it out. The first 6 rows have these variables I told you about. So we're going to use a little bit of dplyr and tidyr to actually get the counts that we want, because they're not here. These are just names. So you'll remember this pipe operator. You take your data, pipe it into group by. So what we're interested in is the number of medals of each type, each year, for each country. So we'll group by all 3 of those variables. And then to get counts, we use this summarize function and define a new column called count, and that's this n thing. And we're going to store it in this new data frame medal counts. And if you just print the head of that, here's what it looks like. So the first column is the type of medal, the second column is year, country code, and finally we have the counts that we wanted. So we've gotten rid of the names, now we have numbers. And you learned a little bit about tidy format yesterday, I think. So tidy format has each variable is a column and each row is an observation. And that's great, but sometimes it's actually useful to work with untidy data. So let's make it wide again. And for that, we're going to use the spread function. So we'll have each column, or each medal be its own column. So we put that into spread, and the key is medal. And then just below here, if a country didn't get any, say, bronze medals, there will be an NA there. So we don't want NAs. I just put in zeros here. And now if you look at it, this is what we have. So this is our untidy. This is our tidy data. We're going to work interchangeably with both of them. And then in some plots, this is going to be too much. We don't want to look at every country, every medal. So I just subset it down to USA gold medals. And this is using dplyr filtering. So that's just preliminary. This is the data I'm going to be plotting. But let's look at base graphics now. So you've seen this already. A general call to base graphics looks like this. You say plot, and you need an X and a Y. And then the ... is just additional arguments you can pass in to customize your plot. So one of them is type. That says, do you want to plot a scatter plot? Do you want to plot a line plot? Or there are a bunch of different other types you can look up in the help. Main is a title. XLab and YLab are labels. And I think we saw call yesterday. That's the color parameter. So here's just X and Y, not putting in any arguments, and this is what it looks like. We get a scatter plot of year against the number of gold medals won. It's pretty ugly, so let's try to do something else with it. So this is the same X and Y here, but now I've said I want it to be a line graph. That's usually nice for time series. And actually I put in USA gold medals here. So we have trends in the number of gold medals won in the US. I put a title with the main and labels. And now suppose I want to add something else. I want to call out this one point. 1984 seems to be the year with the most gold medals. You can call another function to add sort of another layer to the plot. So here I called points, and I use the same format for that. Pass in an X and a Y, and the color, and the plotting character PCH. And that just adds this little red dot where you want it. So that's standard plot. There are other functions in the base graphics that we've also seen, so I'll go through them quickly. Box plots are good for comparing distributions side by side. Histograms are good when you have just counts and you want to see how many times something occurred. And a density is like a smoothed out version of that. So you call density first and you pass it into plot. Bar plots are for plotting single numbers when you have categories. So here I'm saying each year is a category and I want to plot the height, the number of times something occurred as the height. And then a mosaic plot is using area to show proportions in both the X direction and the Y direction. So the vertical here is like the relative proportion of each metal type, and then the Y, I think I just flipped X and Y. The horizontal axis is showing the year. Baseplot does this cool thing where it can recognize the type of object you're passing in. So up above, I was just passing in X and Y. But often you'll have other types of things, and people have written R code such that plot interacts nicely with them. So, and this doesn't happen in Lattice or Gplot. This is exclusively for base graphics. So one example of that is when you have a linear model. This is a silly linear model. You wouldn't actually do that in practice, but suppose we're predicting the number of gold medals based on the number of bronze and silver won. So we can fit that linear model object. And down here, if you call plot on that object, then it knows what to do. It recognizes that it's a linear regression, and it says, okay, I'm going to plot these diagnostic plots for you. So if you've done regression, you'll recognize these: residuals versus fitted. Normal QQ is for testing the errors. And this which argument says, I only want to print the first two of these relevant plots. So actually there are, I think, 4 or 6 linear model plots that R will do for you. It will also recognize data frames if you pass them in. So here I took the metal counts and I took out the country code because that's not a numeric variable. And it recognizes, okay, this is a data frame with numeric variables. I'm going to do scatter plots of each pair of variables here. So you can see the correlation between every pair of variables in your data set. So this is the number of gold medals versus the number of bronze medals. And this can be useful just the first time you're looking at a data set to see rough relationships. But like I said, base graphics is not the most attractive. It takes a lot of work to customize it, but it is good for exploratory data analysis and just running quick sanity checks. Are there any questions before I move on? Cool. Okay, so Lattice and Gplot are 2 newer packages that people have written for R to make prettier graphics. So Lattice is a little bit faster than Gplot, but you won't notice unless you're plotting huge data. The calls to Lattice look a lot like base graphics, so it's simpler to use at first. And it makes nice trellis graphs, so we'll see those later. And it makes 3D graphs, which Gplot cannot do. Gplot, Hadley Wickham thought really hard about how to build this package and make it really elegant. So the syntax is kind of funny, but it's very logical, and once you learn it, you see there's a lot of thought that went into it. It's better at comparing categories of things on the same plot, whereas Lattice is good for making these side-by-side trellis plots. And you can do maps with Gplot, which is great. So Lattice, here's what a basic call to a Lattice function looks like. It'll take in a formula and your data frame, and then some additional options. So like I said, this looks a lot like base graphics. One thing that's a little tricky is that each type of plot has its own name, and they're ever so slightly different from base graphics. So you have to remember them correctly when you're using them. So if you want to do a scatter plot, it's an XY plot. Bar chart. BW plot is a box plot. Histogram is a histogram, whereas in base graphics it's hist. And Cloud does 3D plots. So base graphics, you typically pass in XY. Here we do formulas. So if you just want to look at one variable, you do this tilde y. If you want to look at x and y, you do y tilde x. And you've seen that in some of base graphics too. So that shouldn't be new. But now Lattice does this trellis thing where you can compare groups side by side. And that's what this bar A means. It means look at the relationship between y and x, conditional on groupings defined by A. And then there are a bunch of other formulas as well. You'll need to look them up as you go. So I just went through and recreated all the graphs I showed you in baseplot in Lattice. So here's that scatter plot. You just use XY plot. And you can make a line graph the same way. It's XY plot, type equals L. Here is a box plot. But you'll notice it's different, right? So the years went away. They got changed to numbers. and it's sideways. So there are two modifications you have to make here. Does anyone know why the numbers showed up instead of the year? Any ideas? Yeah. So we talked about it yesterday. Factors are coded as numbers, like behind the scenes in R. And so Lattice knows, okay, this is a factor. I'm going to try to convert it to something I know how to plot. And it just took those behind the scenes labels. So if you explicitly tell it, I want to plot a factor, then it keeps the labels. And I didn't spend a lot of time trying to make this look nice. If you were to make this plot, you would probably want to do something so that the numbers are not overlapping. But there you go. The years are there. And then I did horizontal equals false to keep it from flipping. So I think I actually reversed the order of the y and x and said horizontal equals false. So this was not intuitive, and a lot of times when you're making plots like this, you're going to have to keep iteratively changing things to figure out what works and what you like. So this is just one example. Okay, so here's just a basic histogram of the number of gold medals won. Here's that tilde formula. Here's a density plot. That's a built-in function in Lattice. Bar chart. So to wrap up, Lattice is good for comparing cross-sectional variation, and I actually haven't showed you any trellis plots yet, but we will get to it. I guess it's a con that plots are just made in a single function call. You can't like add more layers to it. And so everything I showed you was pretty basic, right? But if you want to get really good at customizing Lattice, you have to learn all the specific parameters to each function. So it's pretty dense. My personal favorite is Gplot. And if you look at this generic function call, you'll notice it looks totally different from what we're used to using in base R. So we say ggplot, pass in the data, and then there's this AES thing that wraps around the x and y you're passing in. And then there's a plus operator and this long function call where you string together different functions. So it plots things in layers. That's what's happening with these plus signs. And in theory, you could even pass in new data as you go along in these layers. So you can see how the layers work if we do some layers and plot them in sequence. So what I did here, I actually saved this plot object. So this is something I think you cannot do with base graphics. Plots are created as a side effect in base graphics. So you'll run a function call and a plot pops up, but nothing is saved. With ggplot, you run this call and you can save it. So it creates the plot as an object. So what I did here was call ggplot on this medal counts, and I want to make a scatter plot of year against gold medals. And I want it to be a scatter plot, so I say geom point. So that's picking out the point geometry. And I tell it I want them to be gold. So I save it and then I print it here. That's what it looks like. And now say I want to add silver medals to this plot. So what I can say is take the plot P and add more geom points to it, where we have x-axis as year and y-axis is silver, color is gray, and then I add a y-axis label to it. So here's what that looks like. It's added new points, and it took this, where the y-axis was already labeled, and it changed it for us. You couldn't do that in base graphics. It would like overplot things and not format it right. So, like I said, Gplot has kind of odd syntax. It's different from base R, and that's because it's built around the idea of a grammar of graphics, where there are different things. So here are 4 of them. We have statistics, which are the things that we want to plot, the information we want to convey. We need a coordinate system to plot them on. And in Gplot, we have 2 axes. In Lattice, we can have 3. Different geometries to convey those statistics. So that's what all these geom underscore things are. And then scales to show variation in statistics. So Gplot is written so that you can manipulate all 4 of these things. All right, so that was a bit of theory about it, and here I just ran through and again recreated those plots from the beginning. So here's.
Can I just point out one thing?
Yeah, please.
So if you're looking at this where you're stringing together the different columns with the pluses, if she had only done Gplot of metal counts y and aesthetic x and y there, and then just tried to plot that, I don't think anything would have plotted.
Correct. I think it might give an error.
Find the geom point that says what I want is a scatter plot.
Right. Thanks, Chris.
All it does is it just says, oh, the x and the y are the coordinates, and then you're like, okay, well, what happens next?
Right.
Why you need to keep layering stuff on top.
Exactly. Yeah. So all these plots I'm going to show you basically start off the same. They have this Gplot where you give it the data, the AES, x, and y, and then what you customize is the geom you want. So here's a geom point. If you want a line graph, you have geom line. You can do geom box plot, and again, I had to explicitly change year to a factor. Otherwise, Gplot would have done it behind the scenes and not plotted the right labels. There's geom histogram, geom density, geom bar. This one is tricky, and it always foils me. Because Gplot wants to count up the things that you're passing in. So if you're passing in counts already, it's going to try to count the counts, and it will not plot what you want. So you have to explicitly say, plot the stat as the identity. So the thing I'm passing in, plot that. So Hadley Wickham wrote dplyr, which is all about tidy data, and he wrote Gplot. And they interact great, but Gplot has to have tidy data as an input. So this can sometimes require extra fudging with your data to get it in the right format. But if you're using baseplot, you don't need it to be in tidy format all the time. So I just did a comparison of plotting untidy data in baseplot versus an elegant call to plot some tidy data in Gplot. So what I did here was subset the data to just United States. And I want to plot the time series for gold, silver, and bronze metals. In base graphics, you would plot one of those lines. So I plotted year against gold, and I said type equals L, and I want it to be green. And then you have to add the other lines as additional layers to the plot. So it's as though they're their own data sets. You call lines twice, and then you have to stick a legend on there. And you have to do the legend manually, right? So this is 4 lines of code. Gplot, you say, I have my metals data, I want to plot year on the x-axis and the count on y. And now metal is an aesthetic parameter. It's another variable that differentiates kind of points. And so in my geom line, I want metal to distinguish, or color to distinguish type of metal. So ggplot does that all, and it makes a legend for you.
Is that in this case, I think it's the case that you, in one of the versions of the data set, you had a gold column, a silver column, and bronze column. But I think when you're passing in the data into this, you have a column that is the kind of metal.
Exactly. So that's in tidy format, where your variable is metal. Whereas here, I use the untidy, where each metal count is its own column.
How did you change color?
Yeah, that was my question, because in this one it's really obvious how you would change them to be gray and gold, but
I think these were defaults, actually.
yeah.
Maybe,
But that's why it's more elegant. Maybe.
no, changing color I think would just be one additional line. It's a scale, so there's like it would be plus scale. I don't know off the top of my head, but I think it would just be an additional line where you tell it the 3 colors you want.
Is count a variable in the data set, or is that you telling ggplot to count the metals?
It's a count. It's a variable in the data set.
Okay.
Yeah. So, yeah. To summarize, metal is a variable when we're using it in ggplot. Yeah.
Could you briefly go over the difference between an untidy plot and tidy plot?
So the difference would be the data, not the plot. So tidy data, the format is each column is a variable and each row is an observation. And on this plot, like a single point is an observation. Does that help at all?
What about the other one?
So on the other one, it's the same. A single point is an observation, but in the data set, there are 3 points in a single row. You'll have the count for gold, silver, and bronze all in a row. And that's 3 observations in a single row.
Whereas in the tidy one, you'll have a column that has a bunch of bronze, gold, silver.
Right.
And then you'll have counts for each one of those. And there'll be only one, there's one, in the tidy format, there's only be one column that actually has any counts in it. Whereas in the wider format, there's going to be a gold column that has counts in it, a silver column that has counts in it, and a bronze column.
Exactly. So this one here is a subset of the untidy data. And here's the tidy data, where we just have all of our variables in columns, and the data is right here. Yeah?
The help file that help Gplot was really sparse. Is there a good place to go to figure out? I'm trying to do your suggestion use scale with second color.
Right. There is a
There's this whole cheat sheet.
there's a whole cheat sheet. So, well, there's the RStudio one, which is nice, but I always go to this website, docs.ggplot2.org, and it's got every function. So it's got all the geoms, and then here are the color things that I mentioned and couldn't remember exactly. So scale color gradient is if you have like a continuous scale. If you have categorical, you can do scale manual and tell it the colors you want. But yeah, this has got everything. And it's got examples too. So if you go into one of the geoms, say, you can scroll down and see different ways to manipulate them and different examples of the plots. Yeah?
the plot of the metals, and if you wanted them to be actually just gold, silver, bronze colors, you just do plus scale manual and then define those colors.
Yep, something like that. Perfect. And the final thing I wanted to say about tidy data in this context was you can pipe things into your ggplot function. So if your data is like in a messy format and you don't want to keep saving new objects as you go, you can use dplyr chains to make it tidy and then pipe that tidy data into your ggplot call. So here's what it looks like if I just take the data I already subsetted and use a ggplot call. Or if I didn't want to save that USA gold metals object, I could just chain it all together. So take the metal counts and then filter it down to gold metals from the USA and use this pipe operator to put it into ggplot. And the pipe operator works by putting that object into the first argument of the function you're piping into. So instead of having to specify the data, you just pipe it in. And here's what that looks like. They're identical. So pros and cons again. ggplot is great because it lets you add things in layers. And as you add layers, it updates the shape and size and orientation of things so that there's not weird overplotting. It requires your data to be in tidy format, which can be annoying sometimes, but ultimately it works pretty nicely. And there's a learning curve. ggplot's really weird when you first start using it because it's totally different from R, but once you get there, I think it's very much worth learning. So here's the part where I just whiz through some comparisons side by side. And stop me if you have any questions or you want to see anything. So here are density plots, your generic scatter plots, line charts, bar plots. There's something weird going on with the counts. That's what's happening up here. But these are the median number of, I think, gold medals for the first 20 countries. Box plots. And I already talked about converting factors explicitly. Here are the famous trellis plots. So here's Lattice. Looks pretty nice. So what I did was I subset it to just these 4 countries. And now I'm doing scatter plots of the year against the number of golds by country. And you can compare them side by side now. So in ggplot, it's another layer called facet wrap, and we're wrapping by country. So that's what the tilde NOC is. And then in Lattice, the syntax is in the formula. It's one of these vertical bar conditioning things.
The great thing about doing this is now we're displaying an outcome as a function of 3 variables. So we've got the x-axis, the y-axis, and then the faceting of the different panels. And we could even add we could add like a 4th variable by having different colors, say, within the different facets. So this is how we're basically trying to go beyond our two-dimensional display on a computer screen or a piece of paper to add in 3rd and 4th, and it starts to get harder to get even beyond that. That's the basic idea here. Saying, how does an outcome vary by more than 2 variables?
Exactly. This is like trying to maximize the information that you have in your plot. This is a bit of a digression, but these are good plots to know about contour plots and heat maps. So the count data doesn't really work for that. So we're using this volcano data set, which is built into R. It's literally the height of a volcano against like its XY coordinates on a map. And if you just look at the data set, it's this big matrix where the row and the column index X and Y, and then the value in the matrix is like the height. So to get it into Gplot, we have to make it tidy. So we melt it using reshape 2. And now when we put it into Gplot, we can give it X, Y, and Z, and then call geom contour. So that'll make this contour plot that shows like each line is a different value, and I think it might go by tens or something. And in Lattice, it's contour plot, and it gives a similar thing, but I think the lines go by 20s now. And Lattice is nice because it labels the values for you. So this along this line here is a height of 180, and along this line here is a height of 160. I think heat maps are more intuitive, at least. So this is conveying the same information, but now using colors to indicate the value in the matrix. So here in Gplot, it's a geom tile. It's actually plotting little tiles for the matrix values. And here in Lattice, it's called level plot. And you can change the color scales if you don't like them. So like I mentioned, in Lattice, you can make 3D plots.
Don't ever do this.
Yeah, honestly, they're not the best. But they're good for like exploratory stuff. If you're the only one looking at it, go for it.
That was not a critique of Kelly. This plot has been in the past week, but just an editorial comments.
No, it's good to know about it, though, you know. So it's the cloud function in Lattice, point cloud. All right, so this is where things get interesting. Those were all just super basic plots, but you're going to want to customize your plots and add as much information to them as you can, and just make them like visually nice to look at. So you should always label your axes. In Gplot, it's more of these layers, so xlab, ylab, and then they've got their own function called ggtitle. In Lattice, it's the same arguments as in baseplot, xlab, ylab, and main. You can change the size of your points by just calling size in geom point. So you can make them bigger, make them smaller, and then in Lattice, it's CEX, and that'll change the size. And I think everything is relative to 1 in Lattice. So you can do colors. It's the same idea. You pass in color to geom point. And there are a lot of different ways to access colors in R. This is something I always have to look up. I can never remember. A lot of them are like built in, so you can just use a string name like red, or I used gold earlier. Or there's this colors function that defines like, I think, hundreds of colors, and you can pick one out. So this is picking out color 11, which is some teal color. And this is doing the same thing in Lattice. It's call instead of color. And then one thing I didn't really talk about is this AES thing in Gplot. So everything you're passing into Gplot is going to be an aesthetic parameter. That's what AES stands for. So X and Y are aesthetics. And you can also pass variables into here. So you can make color a variable. You can make line type a variable. And these can be used this is really powerful for adding additional information to your plot beyond the X and Y dimensions. Uh-huh.
So you add color by way of AES, and then you add what was it a scale? Like what shows, is it a mixture between the two? Or is it the scale that shows it?
So you can pass in, like what I did here. I'm using metal as the color aesthetic. I could additionally tell it, these are the colors I want to use. And that would be the scale command, scale manual.
Oh, so metal serves as, so if there are 3 different metals, so there are 3 different colors, and you specify what colors you want by the scale.
Right, yeah, I just let it stick with the default here, but that's how you would do it. And the tricky thing is, if you want to do this, like use colors to distinguish categories, you have to pass it into AES. You cannot use it outside of AES. So if you try to do that, say color equals metal, you get this error, object metal not found. If you try to put it in quotes, it still doesn't work. That's not a color. But if you say color equals red outside of AES, then it knows what to do. Because red is not a variable. It's a color. So you have to be careful that the things you pass into AES are variables, and the things outside of AES are going to apply to your whole figure.
Yes, the zip color inside of AES is another coordinate. The X coordinate, the Y coordinate, and the color coordinate.
Exactly.
To a particular variable when you set it in AES.
All right, some more things you can change. The point size, point shape. So here you can pass in a number. There's like a list of 20 different point shapes, and they each have a number. Apparently 3 is a plus sign. You can pass in any symbol you want. So here are some tiny W's and some big dollar signs. And yeah, you can do it in Lattice too. You can change line widths and line types. So same idea, they each have a number. 2 is this dash, 5 is a bigger dash, and then you can change the width too, that's size in Gplot. In Lattice, it's LTY for line type and LWD for line width, but same idea. And here's getting back to the aesthetics to distinguish categorical variables. So here, in this first plot, I have these 4 countries, and I wanted to distinguish them. So I used AES line type equals country. And that, by default, picked the first 4 line types and mapped each one to a different country. You can do the same thing with points. So here I did shape and color for country, and it makes a nice little legend for you. And you see, well, it's harder to see here, but they are different. So these are categories, right? But you can also do it for numeric variables. So the number of gold is not a category. And here I used AES color and AES size to show the number of gold against silver. So now we have year, silver, and gold on the same plot, but we don't have 2 different types of points. We're representing gold as an aesthetic parameter. And you can combine these things to add even more information to your plot. So this has gold, country, year, and silver. So you can just keep going. And then I'll talk briefly about fitting curves in Gplot. Yeah?
Can you also control the font that it uses?
uses in the plots for the labels and the title.
Yes, you can make them bigger, smaller, change the color.
Change the font type, like make it something like latex. Because
Oh.
it's only the size that they.
Right. I actually don't know. You'd have to read up on the Gplot themes. You might be able to. So here's a time series plot. And suppose you want to see if there's a trend in your data. Gplot has these nice smoothing lines built into it. So you can say, I want to add a smooth geom, and I'm going to use a linear model method. So it's going to fit a line and put some standard error shading around the line. And there are different methods, so you can use a low-S smoother, and you can also change the bandwidth for that smoother, if you know a little bit about it. So if you make the bandwidth smaller, it gets more wiggly. Make it, you can remove the shading, so this is not always the shading you want. So you can just say standard error SE equals false, and it goes away. Yeah, this is just different methods. And then you can, pass in more AES stuff. So you can get a different smoother for each metal type, is what I did here. So I said, I want a smoother for each metal. So color equals metal. Method is low S, and then I want to get rid of the shading. So standard error equals false, and it puts a separate one for each metal. So the trellis plots are nice, but you don't always want to do that. Sometimes you have unrelated plots that you want to stick together. So you can use this GridExtra package to do it. So here's just a little example. I made 3 plots, and I saved them as objects. So plot 1, plot 2, plot 3. And then you can call grid arrange on those 3 plots and say how you want to arrange them. And then you get them all together. So this is really nice for making reports. Yeah?
Is there a way to line up the x-axis so like the year 1950 knows?
Yeah, that's because these legends are here. It involves some trickery. Basically, any problem you can think of is Googleable. I do not know the answer off the top of my head, but somebody else has had that problem. So yeah, you can remove the legends, or you can resize the top plot, but it's a little bit more involved. And then once you have these nice report-ready plots, you want to export them. So there are 2 basic types. An image. So the way you would do it, I think we talked about this yesterday too. You open up a device to make that image. So here is JPEG. You say what the file you want to save it to is, and then call the plot, and then turn the device off. Pretty simple. And it's the same for vector images. So those are nice because they resize better. So you typically use a PDF, say where you want to save it, make the plot, and then turn the device off. Yeah?
You've seen that dead off before, but can you go over what exactly it's doing again?
So my understanding is this PDF function turns on the PDF creator somewhere in the background in your computer. And then to actually seal it up and make the file finalized, you have to turn the device off, basically. That's the way I think about it, at least. So that's basically what you do for base graphics and Lattice. And I also use it for Gplot. But there is also this ggsave function that does the same thing for you. So either one of those will work. So that's all of the content. Are there any questions? Oh, and I should just say, anything you can think of is on Google. Like once you know the basic tools, be creative, go crazy, Google it, you can do it. You just have to like iterate and play around, but you can make some like really cool plots. Yeah? So it'll be in your working directory, and then you tell it the file name.
So you can do the same things with get WD to figure out what the work directory is, or if you want to set WD, you can set the work directory to somebody else and save it there.
Yep.
Or you can put a either full or not the relative path in the file name, I believe.
Cool.
Any other questions?
Yeah?
So when you were doing some Gplot, you save one of your plots like as a name, right?
Yeah.
But with Lattice, you can run the same plot, but doing this export requires a save.
No. Export doesn't require you to save your plot. It actually takes whatever shows up in this plotting device here and puts that in the PDF.
Okay, so it's a question of whether you are sort of directly putting the plot into the file or whether you've already created the plot. And then you say, take that plot that's already created and put it into the file.
Right. You just have to do it in this order. You say, turn the device on, and then you make the plot. So it's like the plot is created as a side effect. It shows up in your RStudio, but it also shows up in this device that's running. And then you turn the device off, and it has captured the plot.